So hi folks, my name is Achint Thomas. I'm from Scribble Data. I'm a data architect there. Today I'm going to be giving you a lightning talk, a quick talk on sub-ML use case development. So don't scratch your head. I'm going to talk about what sub-ML is all about and talking about how feature stores and what we call feature app stores are instrumental in development of these sub-ML use cases. So a little bit about Scribble Data. We are a feature store company. We have a feature store that does what a bunch of feature stores do, but then we focus on what we call the sub-ML use case domain. We are based out of Bangalore in India and Toronto in Canada. So we have heard a little bit about this today from a lot of the folks who spoke earlier, that there are a lot of different dimensions to data-driven problems, to machine learning problems, and we are seeing this as well. So you have your machine learning problems, and I'm going to put data-driven problems into the bigger bucket. You can look at it from the dimension of complexity. Low problems that are low complexity to solve, all the way to high complexity. Low complexity, you can think of things like statistical averages, simple aggregates, simple models, all the way to high complexity where you have real-time deep learning features on time series, or things like that. You have models that need to be built, data-driven solutions that need to be built for different classes of users, right? So internal users in your organization versus external users. There are a bunch of organizations out there that build solutions, for users and consumers within the organization itself, and you can imagine that the constraints, the requirements for that class of users is going to be different from external users. And the other thing that we're seeing a lot more today is the consumption of the prepared data that come out of these data-driven solutions, right? For the most part, typically, the data has been destined for machine consumption. So data that would go probably sit in a database or go sit in cloud storage somewhere and be accessed using APIs, be accessed programmatically. But there's more and more today the data that needs to be accessed for human consumption. And you can think of, for instance, decision-making applications, for powering decisions that humans need to make, where this would fall under. So if we keep that in mind, we can see that the assumptions that we have made about what the data needs to look like for these ML solutions, and what these ML solutions themselves look like, these assumptions start to change, because typically you'd have you deal with large data volumes, you deal with high performance real-time requirements, you deal with requiring high skilled talent. You need data engineers, you need data scientists in order to build these systems out, build these solutions out. And even the nature of the data itself, you'd look at probabilistically accurate data, right? I mean, you don't care if it's off by in the third decimal place. You just want it to be probabilistically correct. But then there are a lot of problems today. There are a lot of use cases that are coming about where these assumptions start to break down. And I'm going to talk about where these use cases lie. So in the past, what we have seen is that data preparation and data-driven solutions have typically fallen into two large buckets. One is on the lower complexity end for business intelligence, so where you'd have data prepared and then used by a BI system for visualizations and data consumption. And then you have machine learning on the other end, where it's purely programmatically used. But there's this in-between space where there's a growing number of use cases that we call the sub-ML space. And we are seeing a lot of companies and organizations requiring data applications to be built here. So they need data, they need all of the guarantees around data correctness, all of the trust around the ways that this data is generated and delivered, but without having to build complex machine learning models. For instance, simple models, rule-based systems, those are enough. So you can I've given a bunch of examples here. Let's take, for instance, fraud detection, right? So think of an organization that does not have even their first data scientist, or they don't have data engineers, but they would have analysts, they would have humans who are making decisions on fraud that's happening in their world. So a fintech, a new fintech company, for instance, you'd have humans actually doing the detection of fraud, and if you can automate that, make that much faster for them to be able to reduce the time that they spend doing this work, that's a huge improvement of the performance that they have. So the sub-ML problem space is characterized differently from what traditional ML looks at. So where traditional big ML, we look at a few problems where there's high clarity on what needs to be done and where performance is important. Sub-ML, you talk about a large number of problems, this huge space and a long tail of problems with changing requirements. The delivery, which means the data needs to be delivered somewhere, and then the data needs to be consumed. That is full stack, which means that you need to have applications that these folks can use beyond just the data being available somewhere to consume. Timelines, right? You're looking at a large number of applications, so you want to be able to develop these applications very quickly. And I also spoke about data accuracy, where you want very high accuracy in the data itself, because you're looking at things like powering dashboards. You're looking at things like being able to detect whether someone is fraudulent or not. So the paradigm that Scribble has, the system that we have is something that we call a feature app store, where you tack on an app store to your feature store. So your feature store takes care of generating the features, all of your feature engineering, and you have an app store which exposes very simple applications that consume these apps for things like planning, forecasting, for pricing, for fraud detection, for scenario planning, for anomaly detection, for metrics. And you need to be able to give folks who don't have organizations that don't have time to run month-long projects, the ability to compose these apps together, to put together pieces and components that they can build out the solutions quickly. So what we have seen, deploying our feature app store across a bunch of organizations, across close to 100 odd use cases now, use cases that take a couple of weeks to develop as opposed to the typical months. Having feature app store basically helps you to streamline this use case development, because you have a common design language that everyone in the organization talks. You have less coordination, because you have one developer who can build both the feature engineering as well as the apps that consume all of the data from the engineered features. And obviously, because of that, reduced costs, right? All of the pieces that you need for your feature engineering comes as part of the platform. So when we're thinking about building out feature app stores, these are some of the things that need to be taken into consideration. And we see this as the future, not so much in the fact that sub-ML is going to replace ML. There's always going to be a place for both, but in the sense that sub-ML, it's almost like a gateway drug. The smaller organizations that don't have the talent required in-house, that don't have the resources to start investing in ML right away, but they have the data, right? So they can start building out data-driven solutions. What can they use in order to build their data pipelines in a trustable manner and use that data, be able to consume that data? And we see, there's a long tail of these applications. By some estimates, there are 70 to 80% of the data-driven problems in an org fall under the sub-ML category. And the fact that there's such low cost and low risk to experimentation would have organizations experiment with more and more sub-ML use cases.